Good afternoon, children. So previously we discussed the chemical properties of metals and non-metals that we learned like a lab activity. So what we learned? We learned the metals and non-metals react with the oxygen. Metals and non-metals react with the oxygen. Example what? In place of metal we take example is magnesium. In place of non-metal we took example is sulfur. So what we learned? Metal react with the oxygen gives rise to metal oxide. Is it clear, children? Example what we learned? Metal is magnesium, react with the oxygen, gives rise to magnesium oxide. Magnesium oxide. Yesterday what I said? The arrow marks indicates reaction taking place. Whatever may be the substances you are taking, whatever may be the substances are participating in the reaction, they are called as reactants. Whatever may be the substance is forming after the reaction is called as products. Generally, whenever you will observe, in reactant side, how many elements you are taking, the product side also should be equal due to the law of conservation of mass property. But regarding this equalization, you will learn in the 10th class, that concept we will call it as balancing of equation. Balancing of chemical equation. We are not discussing about that. What we are discussing, when metals are react with oxygen, they are giving metal oxide. Example, magnesium react with oxygen, giving magnesium oxide. One more one, non-metal. Non-metals. When non-metals react with oxygen, what will get? Non-metallic oxide. Non-metallic oxide. Example what we learned? Sulfur react with oxygen. We get sulfur dioxide. Suppose if we take excess amount of oxygen, at the time you will get sulfur trioxide, SO3. Is it clear, children? Now little bit extension we are explaining. When this metal oxide dissolve in water, so when the magnesium is burned in the presence of oxygen, we are getting magnesium oxide, that metal oxide, ash, that ash take in a test tube and add some amount of water in the test tube. Take magnesium oxide ash in a test tube and add some amount of water. So when you add some amount of water, the solution what we will get? When the metal oxide adding with the oxygen, whatever may be the solution we will get in the test tube. If we test the solution, with a litmus paper, we will observe that solution will convert the red litmus paper into blue. red litmus paper into blue. So in 7th class we already learned the litmus paper is an indicator of acidic and basic solutions. The solution in which the red litmus paper will turn into blue, that solutions are what in nature? Basic in nature. That solutions are basic in nature. So here when the magnesium oxide dissolve in water, we are getting magnesium hydroxide solution. Magnesium hydroxide solution. It is basic in nature. Is it clear, children? Next, we will see the non-metals. So when non-metal react with oxygen, we are getting non-metallic oxide. Yesterday we learned. When this non-metallic oxide, when dissolved in water, what will happen? When this non-metallic oxide when dissolved in water, whatever may be the solution, we will get that solution if we test with the indicators, that is litmus paper. If you go to higher classes, you will learn so many indicators, that is natural, artificial and olfactory, like that. So many indicators you will learn. But here you are going to learn only the litmus paper. So if we test the solution with the litmus paper, what we will observe means the blue litmus paper will turn into red. We know that the solution in which blue litmus paper will turn into red, that solution is acidic in nature. What is in nature? Acidic in nature. So when sulfur dioxide dissolve in water, you will get H2SO3. When sulfur trioxide dissolve in water, you will get H2SO4. What is the chemical name of H2SO3 and what is the chemical name of H2SO4? H2SO4 is a sulfuric acid. Once again I am saying H2SO4 is a sulfuric acid. H2SO3, here one oxygen is less. This is called as sulfurous acid. H2SO4 sulfuric acid. H2SO3 sulfurous acid. So total, this is the chemical properties of metals and non-metals when they react with the oxygen. So metals when they react with oxygen will give metal oxide. That metal oxides will dissolve in water. Whatever may be the solution we will get, that solution will convert the red litmus paper into blue litmus. That indicates the solution what we are getting, that solution is basic in nature. Similarly, the non-metallic oxides when react with oxygen will give non-metallic oxide. That non-metallic oxide dissolve in water. The solution what we will get, that is acidic in nature. That means what I am saying, metallic oxides are basic in nature, non-metallic oxides are acidic in nature. If you go to higher classes, some exceptions also you will learn. In the metallic oxides also some acidic solutions are there. That exceptions you will learn in the higher classes. Next, the second chemical property, when the metals react with the water. Metals react with the water. So children, you can say simply, sir, when the metals placed in the water, what will happen, sir? When the metals placed in the water, what will happen, sir? So we know the most probably we know what element? Iron rod. That metal if you place in the water, it will happen. Sir, nothing will happen, sir. No reaction, sir. Children, don't say like that. We will see what will happen when the metals react with the water. Now I am taking some metals. First one I am taking potassium. Next one I am taking sodium. Next one I am taking calcium. Next magnesium. Next aluminium. Leftover we will discuss later. First I will take these two, potassium and sodium. Potassium and sodium. When these two, the potassium and sodium will react with water, sir. Obviously, the potassium and sodium can react with cold water also. Potassium and sodium can react with cold water also. Why, sir? Means these two are highly reactive metals. Highly reactive metals. These two are highly reactive metals. Due to the highly reactivity, due to its highly reactivity, these two can even react with cold water also. And one more, this reaction is violent. This reaction is violent. The reaction taking place by potassium and sodium with water is very violent. Why I am saying violent means it releases huge amount of heat energy. It releases huge amount of heat energy. It releases huge amount of heat energy. Any chemical reaction which release heat energy, they are called as exothermic reactions. Regarding these exothermic reactions, more and more we will learn in 10th class and 9th class. Okay, once again what I am saying, potassium and sodium can react even with cool water. They are highly reactive metals, and these two, when react with water, the reaction is violent because it releases huge amount of heat energy, and after a few seconds, it catches the fire. It catches the fire, and these two will burn with a gold yellowish flame. So these two burn with what? Gold yellowish flame. Now the children, you may get doubt. Sir, how these two will burn in water, sir? So I will explain very clearly. Try to understand. Let us take a beaker. Fill the beaker with some amount of water. And add either potassium or sodium metal in this water. Add some metal pieces in this water. Drop some metal pieces in this water. Once it will drop, what you are expecting? The metals will sink or the metals will float? Obviously, children, you will feel that metals are somewhat more weight, they will sink in a water. But here, the sodium and potassium metals pieces will not sink in a water. Because, do you remember, while explaining the physical properties of a metal, I said these two are low density. These two are low density. So when I say metals are having more density, metals are huge density, at the time these two are exemption, I said. So these two are having low density. Due to the low density, these two metal pieces will float on a water. When they will float, when they will float, at the time when they react with water, what will happen? I am writing the reaction here, observe carefully. When the potassium react with water, it will give potassium hydroxide and also release hydrogen gas. It releases potassium hydroxide as well as it releases hydrogen gas. If you observe, sodium react or dissolve in water, it gives sodium hydroxide and also release hydrogen gas. Potassium hydroxide, sodium hydroxide are basic in nature. These are the solutions, and the hydrogen gas, it is a gas. So whatever may be the gas will evolve in the form of a bubbles, they will move upward. In the form of a bubbles, they will move upward and they will settle on the surface of a solution. These hydrogen bubbles will catch the fire. How they will catch the fire? We already learned what? This is exothermic reaction, means it releases huge amount of energy. That heat energy is sufficient for the hydrogen bubbles to catch a fire. Once again, Anna. So when the potassium and sodium placed in the water, it reacts and releases hydrogen gas. When it is reacting, it is a exothermic reaction. I said exothermic reaction means it releases huge amount of heat energy. Because of that heat energy, whatever may be the hydrogen gas is releasing, that hydrogen gas catches the fire. That's why whenever we are placing this sodium and potassium metal in a water, it reacts very violently with a huge flame. That's why we will never store these two metals in the open or when it is contact with the atmospheric. In the atmosphere, we know water vapors are there. That's why we will never store these two in a atmosphere contact. They will store in kerosene. Okay, children? Now we'll go to calcium. This metal also highly reactive only. But when the calcium react with the water, gives rise to when the calcium reacts with water, it gives calcium hydroxide. And release hydrogen gas. Here also hydrogen gas is releasing, but it is not that much of violent. It will not release more amount of heat energy. Due to that reason, it does not catch the fire. Calcium also exothermic only, but huge amount of heat energy will not release. Due to that reason, whatever may be the hydrogen is releasing, that hydrogen will not catch the fire. Is it clear, children? Potassium and sodium, highly reactive. They will burn very vigorously. That's why they will store in kerosene. Calcium is also highly reactive, but it will not release that much of heat energy. That's why we can store openly, no problem. But it will also react with cool water. Then what about magnesium? What about magnesium? This magnesium does not react with cool water. If you go to the higher classes, in the magnesium also different types you will learn. If you go to the intermediate, there you will learn. In that type, some will react with cool water, some will react with hot water, some does not react with even hot water. Like that you will learn in the higher classes. But according to 8th class level, you remember, magnesium does not react with cool water. It will react with what? Hot water. Magnesium react with what? Hot water only. It does not react with cool water. Come back to next. Aluminium. Next I am writing aluminium, iron, zinc, lead, hydrogen, mercury, silver, gold, platinum. Gold and platinum. If you take this aluminium and iron and zinc, this will not react even with hot water also. Aluminium, iron and this does not react even with hot water also. They need steam. They need a steam. Okay, children, what I said? Aluminium, iron and zinc does not react with hot water. It reacts with steam. Okay, now, water vapor. So in the presence of water vapor, they can react and form a base and release hydrogen gas. If we come back, this silver, gold, platinum, if you observe, this does not react with anything. That means with the cool water also it will not react, hot water also will not react, even with the steam also it will not react. That's why when we are wearing the gold ornaments, daily we are doing bath with the hot water, so much stream bath also we are doing, but still the gold ornaments does not react with the cool as well as hot water as well as steam also. Is it clear, children? This is the reaction of metals with the water. So next class we will learn the reaction of metals with the acids and bases, etc. So thank you, children.